When we look at these problems, one of the biggest things we got to focus on is what's going to be different this year because we're segueing into doing proofs. We're going to use algebra as kind of like the gateway because you're already kind of used to how algebra works. So next to the problem, I'm going to make two columns. I'm going to label this column the rule, and this column I'm going to call the use. Now, when you write a traditional two-column proof in geometry, those two columns are one column. You don't separate them out. So in the rule column, we're going to talk about why we know we can do things. What rule am I using? If you think like a lawyer, they'll say, what law are you referencing? What statute? What section? What precedented court case are you quoting? In geometry, it's the same concept. And use, we're going to actually say what we're doing with that rule. So again, thinking like a lawyer, this is where you say, Your Honor, I want to reference State Law 17.5, Section 6. Judge looks it up. He says, okay, how do you think it applies, counselor? And they say, I think it applies because of this. That would be the use part. So every argument has to have those two components. The rule that you're quoting, and then how you believe it applies to this moment. So this is another one from the homework. This was number 9. If I add these equations together, nothing drops out. However, if I take the bottom equation and multiply it by a -1, so times -1 to both sides, I'm going to end up with an equation set up that will let me cancel out the y's. So I leave the top equation alone. The bottom equation is going to become -4x minus 2y is equal to a positive 17. So now if I add those equations together, variable is gone. So let's talk about rules. -17 times -1 gives me a positive 17. So negative times negative, back to positive. Am I allowed to do that? Can I multiply both sides of the equation by a number? Yeah. What rule tells me I can do that? That's what makes this class tricky now. Because it's not enough to say I can do it. You have to say how you know you can do it. And because, again, I can't do that. I'm going to multiply both sides. By -1. That's what I did. But now I need to know the rule that says I'm allowed to. And this might be the kind of thing that you did it last year in algebra, and the teachers all focus on the columns. They don't usually spend a lot of time over there. Because, again, their goal is, can you get to the right answer? I need you to remember the names of the rules. Now, the good news for the algebra stuff, I'll always have the list of rules on the board for you. Because I don't want you to rememorize them for this class. We're just doing this to get used to the process. Which of those do you think applies? Addition, property of equality, subtraction, property of equality, multiplication, property of equality, division, property of equality. And then we also have this thing called substitution, combining like terms, and distributing. Which one seems like it would allow me to multiply two sides of an equation together by a constant? You got it. Multiplication, property. Now I'm abbreviating like crazy up here because I don't have a lot of room. Multiplication, property of equality. That's the rule I'm using. Give you a second to get that down. All right. Equality. Now let's go ahead and add these equations together. Let's draw a line, add them up. X minus 4x is -3x. These guys cancel out, equals 15. A little housekeeping there. Now this one you might not know what to call it because it doesn't seem like I'm doing what the property says I can do. I'm actually adding the same thing to both sides of the equation. X minus 2y equals -2. So I can add x plus 2y to one side. I can add -2 to the other, and I haven't changed anything. So in this case, I use the addition property of equality. What did I do with it? I added the equations together. You're going to ask it, so I'll answer it now. Do you have to write all this stuff out? Yeah. You have to write all this stuff out. When we start doing proofs, you're going to be writing all this stuff out. Because what gets graded almost as much as what you would normally call the work are your reasons why. Think like an English class. Almost every essay is going to have the same thesis. It's all about how you support the thesis that makes your essay different. Addition, prop of E, short for property of equality. We're big on equality in math. Yep, they're actually right there on the board. Yeah, it might not hurt to have those maybe in the margin. At least until you can't remember all of them. They're pretty straightforward. If you're adding to both sides, that's addition. If you're subtracting, that's subtraction. Multiplication, division, blah, blah, blah. Substitution is when you plugged in. Combining like terms is when you match things together on one side of the equal sign. And finally, distribution is when you clear your parentheses. I got to get rid of this -3, so I'm going to divide both sides by -3. That'll give me x is equal to a -5. And that is the division property of equality that I used. What did I do with it? I divided both sides by -3. So again, I can see what I'm doing. The other advantage to writing this out, this is what my algebra students are doing. If you have ever looked on the YouTube channel at some of the other uploads, you'll see work and all the writing next to it. It's because I want them, A, ready for geometry, and B, to be able to track what they did. Because now I can follow everything. I know what they're doing and why they think they can do it. And that's what makes it work better. I'm going to move a little more briskly through the end of the problem. I've got my x, I have to get my y. So I'm going to substitute it in. So -5 goes in for the x, plus 2y equals -2. So I substituted. What did I do? I put -5 in for x. I'm going to add 5 to both sides. So 2y is equal to 3. Addition property. Because I added 5 to both sides. And last but not least, that must mean that y is equal to 3/2. And that's by the division. Divide both by 2. Sir. Not Andy. I'll hook you up with one later. There you go.